So I'm going to start with the sample problem number 1 about the titration of the sodium hydroxide and sulfuric acid. With any stoichiometry problem, we have to start with a balanced chemical reaction equation. So we've got the reaction between sodium hydroxide and sulfuric acid. It's a 2-to-1 mole ratio of sodium hydroxide to sulfuric acid. There's our balanced equation. And just like every stoichiometry problem, we're going to list our given information. The question says we're going to do multiple titrations of sulfuric acid, and each one of them is going to be a 10 milliliter sample. When working with solutions, obviously we want to make sure that we're always working in liters. So I'm going to make a unit conversion here. 10 milliliters is equal to 0.01000 liters. We're still going to take these zeros as significant figures. That's why they're listed there. It tells us in the question that the solution that we're going to titrate is going to be a 0.100 mole per liter solution of sodium hydroxide. And the titration process is going to tell us what volume of sodium hydroxide is necessary to neutralize this particular solution of sulfuric acid. Now, if you look at the data table, it shows you the amount of sodium hydroxide required to neutralize 3 different samples of the sulfuric acid. So realizing that there's going to be error in anything that we do, we want to calculate the average amount of sodium hydroxide necessary to neutralize these 10 milliliter samples of sulfuric acid. The calculation is a straight average since they're all equal. We're going to just simply add those 3 values up, the 12.42, 12.46, and 12.52 volumes of sodium hydroxide. Divide that by 3, and we're going to get an average volume of 12.4666 milliliters. Now I'm going to carry some extra digits as always, and we're only going to worry with our significant figures at the end. So the average volume that is going to be necessary to neutralize the sulfuric acid is 12.4666 milliliters, which once again I'm going to convert that into 0.0124666 liters of sodium hydroxide. Now, just like with our previous calculations in any stoichiometry problem, we're going to take our given information and we want to convert that to moles. And in this case, the concentration equation of the molarity is equal to the number of moles divided by volume. We're going to rearrange that. We're going to take the molarity and multiply it by the volume to calculate the number of moles. So it's 0.100 moles per liter multiplied by 0.0124666 liters. Notice that the liters cancel out, and we're left with moles, which in this case becomes 1.24666 times 10 to the negative 3 moles. Once we have the number of moles of sodium hydroxide, we're going to apply our mole ratio to go from sodium hydroxide to sulfuric acid. They react in a 2-to-1 mole ratio. Hopefully at this point you're able to do these ratios a little bit quicker. A 2-to-1 ratio, we're just going to simply divide that value by 2 to get 6.2333 times 10 to the negative 4 moles of sulfuric acid. That is neutralized by the 1.24666 moles times 10 to the negative 3 moles, of sodium hydroxide. They react in a 2-to-1 ratio. The last thing we want to do is now convert this number of moles into molarity, which is number of moles is equal to, the molarity is equal to the number of moles divided by the volume. We have 6.2333 times 10 to the negative 4 moles, and we do know that these samples here were 10 milliliters, which is 0.01000 liters, to get us a final concentration of 6.2333 times 10 to the negative 2 moles per liter. The last thing that we're going to do, as always, is make sure that our significant figures are correct. This value here has 4. This value had obviously more than 4, but the volumes that we measured were two decimal places, which had 4 significant figures. Unfortunately, we're limited by this measured value here of the 0.100 moles per liter of our sodium hydroxide, which only has 3 significant figures. So our final answer now here is going to have 3 significant figures. There's the third. We're going to take a look at the next number to get a final answer of 6.23 times 10 to the negative 2 moles per liter as our solution, as the concentration of the sulfuric acid that we were titrating.